This video is for the revision of finding the order of reaction. So rate equation looks something like this. Rate equals to rate constant, and these are the reactants. And these are the order. So order with respect to A and B respectively. You won't be able to know this M or N by looking at the stoichiometry. So you can't get it from the stoichiometry. So for example, if I have this stoichiometry here, the rate equation might be rate equals to Ka. It could be rate equals to Ka square, B square. So you see, B might not even be there, or A might not even be there. So it could be just B square. So any of this is a possibility. So we need to do it experimentally. You can't get it theoretically from here. So this is an example of rate equation. This is the rate constant. This is the order. And we can find the overall order. The overall order would be M plus N. So if you have a few reactants here, just sum up all the order with respect to the individual reactants. That will be the order of the whole overall reaction. Order with respect to the individual reactants will cover 0, 1, and 2. But for overall, it could be higher than this, because if it's first order here and second order here, then overall it's going to be third order. So the overall order for this one would be 1, this would be 4, and this is 2. Let's look at the table of results of an experiment here. From this table, we're going to find out the order with respect to H2O2, with respect to I minus, and with respect to H plus. So we're going to calculate the order for each of the reactants, and then we're going to get the full rate equation. After that, we will calculate the K, which is the rate constant. And then perhaps if I vary the concentration, we can calculate what would the initial rate be. Step 1. If you want to find the order with respect to H2O2, then you have to choose 2 experiments whereby the H2O2 varied, which means you can choose 1 and 2, or 1 and 3, or 1 and 4, but you can't choose 2 and 3 because it's the same. So you don't choose that. Secondly, try to select 2 experiments whereby the I minus and the H plus remains constant. This is preferable, but if it's not available, then it's okay. You don't have to always follow this, but it's preferable because it makes the calculation easier. So for example, if I choose 1 and 2, there's a change in H2O2. There's no change in I minus and no change in H plus. This would be the best to choose to find out the order with respect to H2O2. I wrote the rate equation here. And at this point, we don't know what's M, N, and P. So we're going to calculate that. So first thing, we're going to take 2 experiments. We take the rate of reaction. So the rate is over here. So I've showed you just now why do we choose experiment 1 and 2? Because H2O2 varied and the rest stayed constant. Okay, so I'm going to take the bigger figure to put it on top. You don't have to do that, but it makes the calculation easier. So this is the rate. This is the rate of the other experiment. We're going to divide that and fill in all the concentrations for H2O2, I minus, and H plus. There. So the reason we choose those that are constant for I minus and H plus is because we want to cut it off because we have not found out what is N and P yet. So we don't want this to have a figure there. So 1 to the power of anything is still 1. So it won't mess up our calculation here. And K can be cut off. And so now we can calculate what is the order with respect to H2O2, which is this M. So 6 divide 2, that's 3 equals to 0.03 divide 0.01. 3 to the power of M, so M equals to 1. Therefore, it's first order with respect to H2O2. So now we know this is 1. If you want to calculate the order with respect to I minus, so the order with respect to I minus, you must have the I minus varied. Okay, so think of that. And you have to select 2 experiments whereby the H2O2 and the H plus remains constant. Can you think of which 2 experiments? Okay, so it's this 2, where the H2O2 remains constant, the H plus remains constant, and the I minus varied. So this is perfect. So similarly, we're going to do the same as what we did just now, but this time for I minus. So we take this value, write it here, and this value here. K will be cut off. 0.03 and 0.03 came from there. And we know it's to the power of 1 already, but it doesn't matter because it's going to be cut off. And 0.02 and 0.01 came from there. And 0.01 and 0.01. So if we don't know P, it's fine because we're going to cut this up. So 1 to the power of anything is still 1. Okay, next. So 2 equals to, so divide this, 2 to the power of n, so we know that n equals to 1. So both of these are first order. Next, order with respect to H plus, so you know the steps. You need the H plus to vary and H2O2 and I minus to stay constant. So in your mind, probably you already know which 2 experiments to choose. I'll give you a second. Keep in mind that in exams, it could be like 1-3 or 1-4. It won't look so nice. 1, you choose 1-2, and then 2-3, and then 3-4. So it's not always the case. So in this case, yes, we're going to choose 3 and 4. So we take the rate, it's the same here. And this concentration is the same, concentration the same, and this varied 0.02 and 0.01. I wrote it here. So same, and this is the same. So cut, cut, cut. This is the same as well. But if there's a figure here that's different, it's fine because you already know the order. So once you already know the order, then it doesn't have to be the same. So that's why I told you it's just preferable that it's the same. But if in your exam questions it's not the same, no worries. You already have the order. Okay, let's look at this. So I have 1 here. 1 equals to 2 to the power of P. 2 to the power of what is 1? So that would be 0 order. So now I can write my rate equation. Rate equals to K. H2O2 makes a difference. So if it's 1, I can just leave it like that. I minus makes a difference. And the H plus is 0 order, so I don't have to write it in my rate equation. To calculate the K, just take any one of the experiments, fill in the data. So any one of this, so let's say I pick the second one, just fill in all the data, and then you can calculate the K. No matter which experiment you choose, you're going to get the same K. So just get the rate from the table, get the concentration of H2O2 and concentration of I minus, just ignore the H plus. Then you can calculate the K. So I got 0.02. And the unit for rate is mole per dm cube per second. Each of these is a concentration, so mole per dm cube. So I can cut this off. I still have 1 here. So if I'm going to bring it to the other side, it's going to be per mole. and dm cube, and per second is still the same. What happens if we vary the concentration again? So like H2O2, this time 0.02, and I minus 0.02, and H plus also 0.02. So this time we already have the rate equation, so we know that everything is 0.02 here. We can get the rate of reaction from the rate equation. So from here, there, rate equals to 0.02, 0.02, 0.02, and this would be in mole per dm cube per second.